Students, this session we are going to discuss the continuation of the ray optics concept for Cbse, that is mirror formula. Yes, before going to this discussion, as please remember, in the previous videos we discussed the basics of ray optics and basics of mirrors. Okay, kindly revise it for the understanding the concept. Yes. Now please see that students, the first one, first derivation what I am going to derive, that one is a mirror formula. Generally for mirror it is given by 1 by f is equal to 1 by v plus 1 by u. What is mirror formula, sir? It's very simple, which will give the relation between focal length, image distance, object distance. So plus positive sign. So this is what, children? Object distance. Object distance. This is what, children? Yes, image distance. V is what, children? Image distance. Image, or simply I can call it as I. So image distance. And this is what, children? Focal length. Yes, the focal length of the mirror. Focal length. Yes, just see that. In the previous lectures, we mentioned what is a focal length, the principal focus. For example, for a remembrance of the concept, I can say that here, just consider the concave as a mirror. For example, the imaginary line passing through the geometric center of the mirror is called a principal axis, and this geometric middle point of the mirror is called a pole of the mirror, and the point is called principal focus. That means when the parallel light rays, whether it is concave or convex mirror, it doesn't matter. When the parallel light rays falls on the mirror, they will either really converged or appear to be converged. In case of convex mirror, it looks like appear to be converged or really converged. And this point is called what, children? Is a principal focus. This point is called what, children? Principal focus. F. Principal focus means it is a point. Now, the distance between, as Cartesian sign convention, we said that all the distances are measured from either principal, pole of the mirror or optic center of the lens. So, this distance is called as a focal length f. The distance is a focal length, the point is a principal focus. Now, this concave mirror is considered to be a part of an imaginary sphere. This reflecting surface is considered to be a part of an imaginary sphere. This sphere having some center, that center is called what, children? Center of curvature. Yes, center of curvature. And we know that distance between the center and the boundary of the circle is nothing but a radius. So therefore, this distance is what, children? Is a radius of curvature, or simply I can say that r. So this is the what, children? Yes, the terms we must remember or recall related to the mirrors, whether it is concave or convex. Okay, these things we already informed or discussed in the previous lectures, but I just, for the continuation of the discussion, I just reminding this idea to you. Now we will go for the derivation. Okay, so now the first one, what is, children? Mirror formula we are going to derive. So it's a very easy and important question. As you just take the concave mirror, and this is your principal axis, and the pole of the mirror is P, and this is the mirror reflecting surface is curved inward, and let us consider this is a point F, principal focus. This is the point C, center of curvature, or C is equal to what is that, children? Yes, R, and R is equal to 2F, that we will discuss. Radius of curvature is 2 times of focal length. That derivation I will do later now. So now please see that. So suppose you are keeping a real object behind C, that you can take any position of the image to derive it, because it is true for any kind of image position, but for our convenience I can take that object is beyond C. And we know that as we discussed in the video, in the earlier videos, the property of the image, when the object is beyond C, the image will form the what, children? Between C and F. Therefore, let us consider that so now you please see that when the parallel light rays falls on the mirror, and the reflected ray is passing through the principal focus of the mirror. Yes, children. Yes, the next one you just see that. Yes, and you can take any two, but I can take these two rules to easy derivation purpose. and whenever this makes the angle of incidence I, and that will be reflected with the same angle. It will be like this, children. Okay, so you kindly keep that one in mind, that whenever object is beyond C, image will be formed at between C and F. So you just slightly modify the diagram and be careful with drawing the ray diagrams. For us, how to avoid this type of errors or means, since you know the property of the image, so just to fix the image position, just to fix the what, children, image position, and accordingly you can draw the diagram, so you can easily avoid the mistakes in the diagram. Okay, children, now please see the diagram, and these are the reflected rays. As we said, you just make the meeting of reflected rays, that will indicates the position of the image. So therefore this is B dash, and this will be what, children, A dash, image position. Okay, now please see that for the derivation of this, I can consider the two sets of the identical triangle, two sets of the what, children, similar triangles. Two sets of similar triangles, two sets of triangles. One is about the point F and another one is about the point P. Okay, so that idea you just keep in mind to derive this expression, because sometimes students may get confusion about the considering the triangles, similar triangles. But I can say the easy trick: you consider a pair of triangles about the point F and about the point P to avoid the confusion. So now please see that a pair of triangles about the point F, I can say that is A dash B dash F. The right angle triangle, what, children, about the F is A dash B dash F. And you just see that since these rays are very closer to the principal axis, and these rays are called para-axial rays. Para-axial rays means the rays are very closer to the principal axis of the mirror. Okay, children, since it's very closer to that, the length MP is approximated as to be a straight line. Even though it is slightly curved, it is considered to be what, children, as a straight line. Therefore this will give a right angle triangle A dash B dash F, and similarly MPF, and what, children, MPF. Okay, now I consider two sets of triangle about the point F. Now you please see that vertical distance A dash B dash divided by the corresponding vertical distance for the another triangle, that is MP, that is equal to horizontal distance, that is B dash F. So B dash F divided by corresponding horizontal distance for a triangle MPF is what, children, PF. Okay. Sir, how the triangles are similar or identical triangles? For this case we can write like this. Just see that their heights are just multiplied, or this may be slightly larger or smaller, but they are having similar dimensions. The length will be multiples of that, and the angles also same. So angle length, that property we can use. That is that mathematical information not needed. We just consider that these two triangles are what, children, identical or similar triangles. So I can write like this. So you just see the diagram. MP is approximately equal to what, children, AB. So MP is approximately equal to what, children, AB. Therefore I can replace this MP as to be AB. Therefore I can write that A dash B dash divided by AB, that is equal to B dash F divided by what, children, PF. Say equation number 1. And similarly, as I said, the another set of triangle about the point what, children, that one, another one about the point P. So now we please see that the triangle ABP. So next the triangle what, children, ABP, and the another one is what, children, A dash B dash P. So another one is what, children, A dash B dash P. So one triangle about the F, and another triangle is about the pole of the mirror. It's that and all just for derivation. What is that idea to keep in mind, the steps what we must do. Again I can write that vertical height by vertical height. Similarly here also A dash B dash divided by AB, that is equal to horizontal distance by horizontal distance. that is PB dash. That is what children? PB dash divided by as a PB. PB dash by what children? PB. So this is equation number 2. Yes, you just consider 1 and 2 LHS are same. Therefore, from 1 and 2 LHS are same. Therefore, I can write that PB dash divided by PB, that is equal to what children? B dash F divided by S PF. But this B dash F is unknown quantity, is no information. That's why the B dash F can be written as PB dash. That means the distance between pole and the image is nothing but V, image distance. So that can be known quantity. Distance between P and F is what children? Focal length. That also known quantity. So therefore, B dash F can be written as PB dash minus PF. Therefore, I can write that as P dash as F can be written as PB dash minus what children? PF divided by what children? PF. You just divide this and I can write that PB dash divided by PB, that is equal to as PB dash divided by as PF minus 1. Yes. So this is the general expression what we get. Now we have to apply the what children? Sign convention. We have to apply what children? Sign convention, Cartesian sign convention we discussed earlier. PB dash is left side of the mirror. As I said the trick as in the previous videos, you just see that. Or this PB dash is against the or opposite to the instant ray, therefore the sign will be negative. And this PB dash is nothing but what children? Is V. Therefore I can write that by using sign convention, by using what children? Sign convention, I can write that that has to be minus V divided by PB. Again it is left side, or we can say that PB. This measuring direction is opposite to the instant ray, therefore minus U. Yes, what children? Minus U. So this distance is U. But when I am marking in diagram, I am not using any minus sign, because when you are measuring the distance, it should be written as to be normal as a value. But when you are solving the problem or theory, that time you have to put the sign. Okay. So that is equal to PB dash. As we said here, PB dash is nothing but is minus V divided by PF. Again you see that this is the instant ray, PF is opposite to that instant ray, and this PF is nothing but, just now I said, and this is nothing but what children? Is a focal length. Therefore I can write that as to be minus F minus 1. So this minus gets cancelled out. Therefore I can write that V by U, that is equal to V by F minus 1. Now we are going to discuss about the formula that is called magnification. What children? Is magnification. I will give you a separate formula now, but for that concept will be linked here itself. Yes, linear magnification. M is equal to, we can write that V by U. You can write that what children? Minus V by U. We can write that minus V by U minus V by U minus V by U, or that is equal to H image divided by H object. H image divided by what children? H object. Since you just yes, see this expression, what I said children, linear magnification of the mirror is M is equal to minus V by U. But what is here? Plus V by U is there. Therefore, we know that. So, M is equal to minus of V by U, and that can be replaced by V by U can be written as to be minus M. Therefore, the same expression can be written as what children? Minus M, that is equal to what children? V by F minus 1, or we can just multiply with the negative sign, we can get that M is equal to 1 minus V by F. So, why I am telling this expression here itself means, some cases we may not know U value. Yes, but this equation contains only V and F. If you know V and F, you can easily calculate M value. So in this manner we can relate M and F. That's for that purpose only I have done here itself. Yes, even though our aim is to derive the what is that mirror formula. So now you please take this expression and say, for example, I can say this is equation number 3. And this can be equation number what children? 4. Therefore, equation 3 can be written as to be. So, equation 3 can be written as what children? As V by U, that is equal to V by F minus 1. This becomes, you just divided by V, then I can get what, children? 1 by U, that is equal to 1 by F minus 1 by V, or take left hand side, we can get that 1 by V, that is equal to what, children? Or just take that, so 1 by F, this is coming to this side, 1 by V plus 1 by U. Yes, what, children? Yes, this is the information about, or the formula for, yes, what, children? Yes, mirror, or simply we can say that mirror formula, 1 by F is equal to 1 by V plus 1 by U. This is true for any position of the object and any kind of mirror, any kind of what, children? Mirror. Okay, wherever reflection takes place, we can apply this formula, especially in the case of here we will mostly discuss about in the case of spherical mirrors. Okay, children, so this is the derivation for, yes, a mirror formula. The next concept what we are going to discuss is, yes, magnification. What, children? Yes, magnification. Yes, or we can simply say that has to be linear magnification. What, children? Linear magnification. And that now you please see that it is defined in general. M is equal to, I can define this one in two manner. One is in terms of height, another one is in terms of distance. Height means we can say that this is the height of the image divided by height of the object. Height of the image divided by height of the object. This is in terms of height. The another one is in terms of distances. That is image distance by object distance. Minus of V by U, children. Yes, this is the another magnification formula. And now please see that, yeah, yes, this M value only decides, the nature of the image formed by the mirrors. So I can explain that, suppose the sign of the M will be positive, means the corresponding image is called what, children? Virtual image. If you are getting M has to be positive sign, the image will be what, children? Virtual image. So yes, I think it's not visible, so I can write down. Yes, so here, so now please see that M is positive. Positive means what, children? Yes, virtual image. Positive means what, children? Yes, virtual image. Virtual image. Okay, yes, virtual image. And M is negative means what, children? Real image. Negative means what, children? Yes, real image. This is the one information. Okay, and another one is, if you are getting, if suppose I am getting M has to be minus 2, for example, M has, during the calculation, if I am getting M has to be minus 2, the minus represents image will be real. Whether it is enlarged or not, how to find out, Sarna? You just see that, if for example, if you are getting, yes, if M is equal to minus 2, for example, you just assume that the negative sign represents the image will be real. Then what about these 2's are? So you just take the modulus. Now minus 2 become has to be plus 2. Yes, so this modulus, magnitude of M, will gives information about whether the image will be enlarged or diminished or is the same size. Okay, so for that reason you just see that mod of M. So that is, if mod M is, modulus M is greater than 1, or modulus M is equal to 1, or modulus M is what, children? Less than 1. Okay, you please try to understand. Yes, for example, if M is equal to minus 2, this is the actual value what we got during the calculation. For example, this negative sign indicates real image. Suppose if you are getting plus 2 means, plus means what? Virtual image. Yes, now to check whether the image will be enlarged or diminished, whatever you are getting, you just to find the modulus. Minus 2 means modulus is what, children? Plus 2 only. Plus 2 is given already, then modulus of that also as it is plus 2 only. Therefore, if modulus of M is greater than 1, then that is called enlarged image. What, children? Enlarged image. If it is very large, very large means we can say highly enlarged. If mod M is equal to 1, then height of the image is same as to be height of the object. Height of the image is same as to be what, children? That is object size, image size are same. That case we discussed in object at C in the case of concave mirror. And this will be what, children? Less than 1 means diminished image. Less than 1 means what, children? Diminished image. So these are the information about the size of the images by finding the magnitude values. Okay. The next one is power of the mirror, power formula. Yes, power P. Yes. So P is equal to what, children? Yes, minus 1 by F. P is equal to what, children? Yes, minus 1 by F. Since in case of mirror, the negative sign will come. In case of lens, that will be a positive sign, where F is in meter. Where F is in what, children? Yes, meter. F is in meter units. Okay, children. The power unit will be diopter. That and all you know very well. Yes. The another relation what we must is R is equal to 2F. Yes. The relation between radius of curvature and the, yes, what, children, focal length of any mirror, curved mirror is R is equal to 2F. For a curved mirror is, spherical mirror is what, children? 2 times of F. That proof will be discussed as a continuation of this. You please, this is the information about what is mirror formula and what is its magnification. And the relation between S, what, children, M and F are given. Similarly, you can write this one for in terms of U also. So how to do, sir, in terms of U and M, how it will be relates or means, you just take the, yes, what, children, here itself I can write that M also can be written as, from this results I can say that M is equal to 1 minus V by F. This is the another formula which relates only, yes, V, F, M. Suppose U is not known. And again, sir, how can we write this like this in terms of U's or means? You just take the, yes, mirror formula. So I can derive that. So 1 by F is equal to what, children? 1 by V plus 1 by U. So the equation should contains only, yes, U term. Therefore, you just multiply it by, yes, V. So just multiply it by what, children? V. What I will get, children? Yes, V by F. Multiplied by U, then we can get what, children? U by F, that is equal to U by V plus 1. U by V, what, children? Plus 1. Yes, U by V is nothing but, yes, as we said here, V by U means minus of V by U means M. So we are getting only U by V. So this U by V, yes, can be written as, so therefore U by F, that is equal to, yes, this is what, children? Minus 1 by M. Therefore, I can write that as to be minus 1 by M, yes, plus 1. Minus 1 by M, what, children? Plus 1. You just take this negative sign here and reciprocate. Yes, you can get that as to be the result. Therefore, you take this positive sign to that side, plus 1 to that side. Therefore, I can get, yes, children, I can get this has to be 1 minus, U by F minus 1. So from this I can get U by F minus 1, that is equal to minus 1 by F. You just, what, children? Yeah, just cross multiply this. So M is equal to, yes, minus of, yes, 1 by U by F minus 1, or I can rewrite that expression. I can, yes, take this has to be the result. Yes, this has to be the result. Yes. So in that manner also we can relate, yes, M and yes, U. Therefore, I can write at last, I can write here that is, just see that. So M is equal to. So from that you just take that, children. Since there is no space for that, I can write somewhere here. Therefore, yes, so therefore I can write that is U minus F divided by F, that is equal to minus 1 by M. So from this I can cross multiply the results. Therefore, M is equal to, minus is there. So F by is minus F divided by U minus F. Just multiply that negative sign. So I can get this has to be F by what, children? Yes, F minus U. F by what, children? F minus U. So therefore I can write for M in terms of U, I can write that has to be what, children? F by F minus U. This is the another result or expression for SF. We can take the LCM also. F minus V by F will come. F minus V by F will come. Yes. The another information is, even though in the derivations we are used the sign convention, during the calculation During the numerical calculation also, once again you have to use the sign convention. Once again you have to use the what children? Yes, sign conventions here. For unknown quantities, don't put the sign. What are the known quantities are there? For that you just substitute the values, then the unknown quantity will come with the proper sign. As I said earlier, if you want to check your numerical calculations whether it is right or wrong, you must know the nature of the image formed by the mirrors. So that video also we already discussed. So that can be what children? Yes, revise it. Okay. So by knowing the image property, we can easily what children? Analyze whether the calculated value is correct or not, whether it is matching with the property of the image or not. If it is not matching either size wise or sign wise, that means real or virtual like that, then you have to cross check our sign convention used in the calculation purpose. Yes children. So this is the what children? Another information about reflection topics. So far what we discussed is reflection topics. Okay children, please kindly note down the theory part. For this video session is what children? We have to show the derivation for r is equal to 2f. Okay. So now please see that we have to check the relations between r is equal to 2f. Okay. Now please see that a concave mirror is there, and this is the pole of the mirror, and this is called principal focus, and this is what children? C, center of curvature. And in the previous video we discussed how to draw the normal line. All the angles are measured with respect to normal, and for a spherical surface the normal should be drawn through the center of curvature from the point of incidence. Okay, so this is the normal line which is passing through the center of curvature. Okay, normal line. Yes, let this has to be angle theta. As per the laws of reflection, angle of incident equal to angle of I can simply say that this is, for example, I can say this is angle I. Then by property, the rules of the ray diagram, if the ray is parallel to the principal axis, after reflection it will be passing through the principal focus, and angle of incident equal to what children? Angle of reflection, that is I is equal to r here. Yes, in this diagram this is angle of incident I, this is angle of reflection r. Okay, so yes, now please see that this is the point M where the light ray is incident, point M where the light ray is. For the small paraxial rays, this may be assumed as to be a straight line. This may be assumed as to be what children? Straight line. So now you please consider we are getting the two sets of triangle. One is the right angle triangle is what children? Yes, I can, for your better understanding, I can draw that diagrams here once again. So this is the a triangle what we get. Yes, this is what children? Yes, okay. So this is C and this will be F. What children? Yes, or I can redraw the diagram for your better understanding. You just see that. So for this right angle triangle, that is MPC. So for the right angle triangle, what children? MPC. So this is angle I. This is vertically opposite angle. So this angle also what children? I only. So therefore for this purpose, this is your right angle triangle C, and this is P and M. This angle is I. So what children? Opposite side by adjacent side. Therefore tan I, that is equal to, for small angles tan theta is approximately equal to theta. Therefore this can be written as I. So approximately equal to what children? Is I. Okay, so that is equal to opposite, that is MP divided by PC. MP divided by what, children? PC. This is expression for the theta or I, we can call it as. Okay. Now we consider this. This triangle is what, children? Is MCF. For this triangle MCF, this is angle of incident equal to angle of reflection. Therefore, I and this is. So we know that the property of the triangle, sum of inner opposite angle is equal to outer angle. Sum of inner opposite angle equal to what, children? Outer angle 2I. Therefore, in this right angle triangle, what, children? MPF. In the right angle triangle, MPF is, it will be like this. So this is F and this is P and M. This is 2 times of the angle, yes, 2I. Therefore, I can write that tan 2I, that is equal to what, children? Yes, just see that MP by PF. Therefore, MP by, yes, PF. MP by what, children? PF. For small angles, I can approximate that has to be 2I. I can approximate that has to be what, children? 2I. You just compare these two relations. Therefore, I can get that, yes, 2 is equal to, just or we can easily substitute that. So, therefore, I can say that MP by, yes, PF. MP by PF, that is equal to 2 times of I is nothing but MP by PC. Therefore, MP by what, children? PC. So, MP gets cancelled out. So, just cross multiply. So, PC is equal to what, children? 2 times of PF. P is equal to what, children? 2 times of PF. Okay. So, therefore, PC is nothing but radius of curvature as we discussed earlier. Therefore, R, that is equal to PF is nothing but yes, what, children? Focal length. This will be focal length and this will be radius of curvature. Therefore, I can say that is 2 times of F. So, this is the equation where I am not using any sign convention. But in the case of as a concave mirror, so we see that F value for as a concave mirror, yes, whatever may be the position of the object. Position of the object is immaterial. For concave mirror, we can yes, see that the F value will be what, children? Negative sign. For convex mirror, the F value will be what, children? Is positive. F value will be what, children? Positive, irrespective of the position of the object. Whether you are keeping at infinity, beyond C, at C, it doesn't matter. F doesn't changes for these mirrors. Concave means negative and convex means positive. Yes. Therefore, we can say that R is equal to minus 2F. R is equal to what, children? So, R sign will be negative. So, negative for concave mirror. So, negative for concave mirror and positive for what, children? Convex mirror. Positive for what, children? Convex mirror. Okay. Yes. So, this is the information about a spherical mirror. Yes, and the mirror formula, yes, and the related concepts. Okay. These are the important area. If you are understanding this, we can easily solve the numericals. The idea for lenses also very similar to this case with a slight modification. Yes, children. So please yes, watch our videos regularly, and if you have yes, you can get the clarity about the content. Yes, and you can give your feedback for our yes, improvement. Yes, thank you, students.